Hello, future doctors and engineers. So, I welcome you back to the universe of physics where tough physics concepts become super easy for NEET and JEE. In the previous video, we have solved the free body diagrams related to block problems. In this video, we're going to solve the exact type of problems that NEET and JEE love to ask step by step without confusion. In this video, we will discuss the pulley problems or the free body diagrams related to pulleys. So let's get started. So this is the first free body diagram for pulleys. This is a simple Atwood machine beta. In this case, two masses are hanged on each side of a string which is connected to a fixed pulley. So this pulley is fixed and this pulley is also massless. Okay. When the pulley is massless, the tension on each side of the pulley in the same string will be same. We have to remember that. I'll write it here. Now, to draw the free body diagrams, let's think which are the forces acting on the block, which are the forces acting on the block, on the blocks. So beta, you can easily remember that if the block is hanging in midair or is placed at somewhere, so there will be a gravitational force acting on the blocks. So the first thing which will come into our mind is the gravitational force acting on both the blocks, and this gravitational force is obviously downward. So to draw the free body diagram, we first place the gravitational force downwards on each block. Now, if we say that any one of the block is heavier, then it will try to pull the system on its side. So when it try to pull the system on the heavier side, the the lighter side will try to pull it down on the other side. M2 is trying down to pull the system in left direction. M1 is trying to pull the system in rightward direction. That is why there will be a tension in the string. And as I have said earlier, the tension will be same on both sides. The tension will be same on both sides. Why it is beta? Because the pulley is massless. That is why the tension will be distributed all along the string as seen. Okay. So if we draw the free body diagram of the blocks individually, we will get M1G and T. Okay, for M1 obviously, and for M2 it is M2G and T. So I hope you understand the first problem. Okay. This is the second problem we are going to discuss here beta. Here we can see that there are three blocks and two strings. So the second thing you have to remember that if the string is different, if the string is different, tension will be different. Tension will be different. Okay. So here there are two strings. In the first string, we can say the tension is T1. But in the second string, we have to write tension as T2. But in the second string, it is connected to a massless pulley. So the tension will be same throughout the string. So in the second string, tension will be same at each point. In the first string, tension will be same at each point. But in two different strings, the tension will be different. Now, we have to think about the gravitational force. So on the M2, the gravitational force is downward, that is M2G. For M3, it is downward M3G, and M1, it is downward M1G. Please focus on this gravitational force, which generally student try to, or maybe generally student miss this M2G because they more think about the T1, but they tend to miss M1G. To please focus on this M1G. Okay. Now, if we individually draw the free body diagram of the three blocks M1, so there will be a tension T2, there will be a tension T1, and there will be a M1G. If we draw the free body diagram of the mass 2, so there will be a M2G in downward direction. There will be a tension 2 which is acting on the M2G. And if we draw the free body diagram of the mass M3, then there will be a M3G and there will be a tension T1 which is acting upward. Now the third system, this is a bit easier system because one of the block is on the flat surface, the second is hanging in the midair. So if we talk about the first thing, that is the gravitational force acting on the blocks. So this is the first gravitational force on M1, which is M1G, which is trying to pull the system downwards, and due to which there will be a tension in the string. As we have already discussed, the string is same though, so the tension is same at the each point. There will be a M2G. Now pause the video and think of it that if we have completed the free body diagram, think about it for a little bit. Yes, you are absolutely right. We have made a mistake that there will be a normal on the M2, that is N. Why it is so? Because this is connected to a surface. So if it is connected to a surface, there will be a normal. But M1, it is not connected to any surface. That is why there will be no normal on M1. It is hanging in mid-air. So if we want to draw the free body diagram separately or individually, so in the case of M1, we can say that M1G is acting downwards, tension is acting upward, M2G is acting downward, there will be a tension which is acting rightward, and there will be a normal which is acting upward. So this is the individual free body diagrams of the blocks. We can write M1 here. So I hope you understand the third system. Let's get moving with the fourth system. So beta, this is our fourth system in which now we are having two pulleys, two strings and two blocks beta. Okay. So let's firstly denote the gravitational force. So this is M2G, this is M1G, this is a single string which is having a tension T1, but you can see this string is throughout the block, the first pulley to the third, maybe the second block or second pulley. So for this whole string, this whole string, this first, second, okay, the whole string, the tension will be same. Why it is so? Because the string is same and the pulley is massless. Okay, that's it. So if we draw the individual free body diagrams beta, we can write the first M1, M1G is downward, T1 is upward, and for M2 we can write beta T2 upward and M2G downward. Here we can also draw a free body diagram of the pulley which is not fixed. This is a movable pulley. So it is experiencing two tensions like T2, T2 and T1. There will be no gravitational force as the pulley is massless. But this pulley is going to create wonders in the equation making, which we will discuss later. So this is it for today. you liked the video, please share it to one of your friend who is serious about the preparation, and please do like and subscribe the channel. That's it for today.